Okay, so this came all the way from Great Britain. I've been looking for this for a long time, and so I want to share it here. It's a description of Edison's original nickel-iron battery, the defective ones, the ones that he recalled. I don't know if there's any in existence anymore. He recalled them all, and he wouldn't sell them or anything like that after he discovered the problem with them. So the date on this is July 1st, 1904. And it describes the recalled ones. So I haven't been able to find a good description of the recalled ones. And the main problem that I've been led to believe is he used graphite, and it went haywire. So I'm going to go ahead and try to read this for you. Go ahead and follow along if you want. It's quite a long article. I better get started. I'm using a new camera. It's called the Dragon Touch. So let's see how far I can get. And I want to eventually have a Edison battery encyclopedia published. I'm busy collecting materials over the last 10 years. And this will probably be in there too. So anyway, the Edison storage battery. Several weeks must necessarily elapse before any description of the electrical exhibits now slowly falling into the order at the St. Louis exhibition can be usefully attempted. That a far greater number of objects of high interest than can be dealt with in a limited series of articles will ultimately collected in the electrical building is apparent. It is also evident that in very many cases the objects exhibited give no measure of their importance or of the details of the manufacture, which can only be properly understood from their sources of origin, in most cases far removed from St. Louis. This is essentially the case with one of the most remarkable of Thomas Alva Edison's exhibits, his storage battery, brought into a practical form after 7 years' investigation, and about which a large amount of interesting information and not a few exaggerated stories have been written. The finished cells, identical in their appearance, give no indication of their construction. Their characteristic diagrams that form or will form part of the exhibit are full of interest, and the component parts of the cells, dissected and placed on view, scarcely suggest the beautiful mechanism by means of which they are produced at the Edison Storage Battery Works of Glen Ridge, New Jersey. Thanks to the courtesy of Mr. Edison, we are enabled to describe in detail the construction and characteristics of his storage battery in its most recent form, as exhibited at St. Louis. The conditions that Mr. Edison considered should be fully fulfilled by an evident storage battery, an efficient storage battery, are as follow. 1. That no corrosive acid should be used. 2. That all the active materials used must be insoluble in the liquid. 3. That the liquids should remain the same under all conditions of charge and discharge. 4. That the materials should be light in weight. 5. That the mechanical construction should be strong. 6. That there should be practically no disintegration or deterioration from use. 7. That the operation of charging and discharging the battery and its care should be of the simplest possible character. 8. That it should not be injured by overcharging, by heavy discharges, by discharging to zero, by standing charge, partially charged, or completely discharged for any length of time. 9. That the rate of charge and discharge should be high. 10. That the weight per horsepower per hour should not be excessive, and the capacity constant over long periods of time. Some of the foregoing conditions appear conflicting and difficult of accomplishment, but it would seem that the Edison battery, now manufactured on a large commercial scale, has fulfilled the prescribed requirements with remarkable success. So far as durability is concerned, experiments with the battery on automobiles in regular working over a period of 3 years show no appreciable deterioration mechanically or electrically. A special feature is that the metal of which the cell is composed is steel. The grids and boxes that carry the active material, the connecting and binding posts, the spacing washers, nuts containing envelope or jar and cover are all made of steel. In fact, the entire cell is constructed of the same metal except for a small amount of hard rubber used to insulate the plates from the sides, bottom, and cover of the containing envelope, and each adjacent plate from its neighbor. Consequently, the cell is of very durable character. Each piece of steel employed in the construction of the battery is, previous to being used, covered with nickel by a special fusing process that adds materially to its durability and finish. The skeleton of each cell consists of a number of thin steel plates punched with rectangular openings. The form of these grids is shown on Figure 1 on page 2. The punching department, which the steel grids are made, is fully equipped with special machines. The same remark applies to all the other departments throughout the works. It may be mentioned here that the plant is in actual use has been evolved from a number of specially constructed machines, which, although capable of performing the work, could not be operated at sufficiently high speed. The steel from which the grids are made is delivered at the works in long strips of the required breadth. These are cut to gauge lengths by shearing machines, and each strip is dipped into oil before passing into the punching machine. This latter produces one complete grid each time the die descends, cutting 24 rectangular holes in the blank plate for the reception of the perforated boxes which hold the active material. At the same operation, the plate is cut into shape and the hole in the top lug is made. After being thus formed, the grids pass on to the nickel plating department. The most interesting and ingenious details of the Edison storage battery are connected with the perforated boxes or pockets which hold the active material. A whole series of special machines have been designed for their production. 2 floors of the factory above the punching department are devoted to the manufacture of these intricate parts. The material from which the boxes are made is a very thin steel ribbon, a little over ½ an inch broad, and only 1/3000th of an inch in thickness. In a few words, the process by which they are manufactured are as follows. The strip of steel enters one side of a machine provided with 2 perforating wheels, one male and one female, and comes out on the other side so finely perforated that there are not less than 2,500 holes in a length of metal required for one pocket. On each side of the perforations, a narrow strip of plain metal is left. This is used subsequently to form the angles of the box. Outside these plain surfaces, the machine forms a very narrow milled line, the markings of which, by the casual observer, could easily be mistaken for perforations. These are of the same size, but do not penetrate the metal. These ultimately form the long sides of the pocket, the milling giving a certain roughness which assists the methods used for retaining the pocket in the grid. Finally, the extreme edge of the strip is left plain to form the edge of the box. The minuteness and accuracy of these operations will be appreciated when it is remembered that the width of the steel ribbon is only a little more than ½ an inch. It, may be added that the machine at present in use delivers 30 feet of perforated strip per minute. The ribbon is now tested in order to ascertain that every hole is perfect. This is done by passing it over a slot in the top of a box with a light inside. A standard piece is held inside the strip under test, and a comparison of the two is a quick and ready method of detecting any fault. Formally, the strip is passed after a test to the machine for producing the boxes, which were then nickel plated. But the metal frames used to support the boxes took so much of the nickel from the bath solution, it became so heavily plated themselves, that this process proved too costly and is now abandoned for one that is found more advantageous. Well, I can't keep reading this, it's too lengthy, but let's go over the drawings, and I'll do a quick once over of the pages here, and maybe that'll allow you to see what I don't read here. I'm having some solar problems. You can hear the inverter working in the background there. It's having issues, so let's go over I'm going to read all of this. So hopefully you can pause it where you need to see information. Like I said, I want to do a nickel iron battery cyclopedia. This will probably be in there. Obviously, it's public domain information now. So this was the original attempt. Like I said, that it didn't make it right. Something went south with the get all that with the design. And then he recalled them all, and you probably can't find them anymore. Because you probably recalled them all and tested them all and destroyed them all. This talks about it, and it's hard to find information on it. I think he wanted to get rid of the mistakes pretty completely. That goes into tool grinding. But yeah, if you ever do think you can see one of these are recalled ones. Just look at the top. The top is a lot different from the ones that actually were approved. And the wood case is different and stuff like that. So I gotta go. My inverter's dying. So like that. So okay, back to research.